All right, let's get right into it. We're going to play detective and hunt down the real reason our favorite apps and websites sometimes just crawl. It's a super common mystery, right? But the answer? It's probably not what you're thinking.
I mean, you know the feeling. We've all been there. You're scrolling, you're clicking, maybe trying to check out, and then nothing. Everything just freezes. 1 second it's super snappy, the next you're just staring at that dreaded loading spinner. So what is actually going on behind the scenes?
So to figure this out, we've got to bust a really common myth first. Most of us, and yeah, even some developers, tend to focus on the average speed of an app. But as you're about to see, that average, well, it can be a real liar.
So this is where our whole perspective has to shift. We're so used to asking, okay, what's the average speed? But really the question we should be asking, the one that actually matters for, not wanting to throw your phone across the room, is how reliable is it? Think about it. A system that's just consistently decent is way better than one that's sometimes blazing fast, but other times just completely awful.
Okay, so if the average speed isn't the bad guy here, what is? It's time to pull the mask off the true villain, a little metric that's usually hiding deep in the performance data.
First up, just a quick definition so we're all on the same page. Latency. It's just the time it takes from when you do something, like you click a link, to when you get the response. Simple as that. The total round-trip time.
And here it is, our culprit, P99 latency. Now, this isn't about your average everyday experience. This is all about your worst experience. P99 basically tells us, hey, 99% of your requests will be this fast or faster. It's a way to zoom in on that slowest, most frustrating 1% of interactions.
And this quote just nails it. We're looking at the worst performance you can pretty much expect on a normal day. We're ignoring the really, really rare once-in-a-blue-moon disasters, but we're keeping a super tight focus on those frustratingly slow moments that happen just often enough to really annoy people.
Okay, but 1%? That sounds so small, right? Why are we even talking about it? Well, because when you're talking about huge systems, 1% isn't small at all. If your service handles 1 million requests a day, that so-called rare 1% means 10,000 people are having a terrible, slow, frustrating experience. And that's happening every single day. These are the people who leave, the ones who abandon their shopping carts, the ones who write those angry one-star reviews.
And believe it or not, it gets even worse. See, modern apps aren't just one big thing anymore. They're built from lots of little microservices. So if your web page needs to talk to, say, 5 of these services to load, and each one has that 1% chance of being slow, well, the odds that your entire page will be slow just went through the roof. A 1 in 100 problem for one service just became a 1 in 20 problem for you, the user. That's the compounding problem, and it's a huge deal.
All right, we've identified the crime, these really painful, slow experiences. Now let's do a police lineup and check out the usual suspects that cause them.
And wow, this really shows you just how complicated things are under the hood. An app isn't just one thing. It's this whole stack of different technologies. You've got the runtime like Java, the platform like Spark or Cassandra, and then your actual application code on top of all of it. A slowdown could literally come from anywhere in this pile.
So here they are, our main offenders. You've got things like garbage collection, which is when the programming language literally hits pause on everything to clean up memory. Then there's queuing. Your request is basically just stuck waiting in line. Network glitches, lost data packets, even the operating system itself just deciding to work on something else for a millisecond. And then the cloud, you can have noisy neighbors, other apps on the same machine hogging all the resources. Any one of these can wreck a perfectly good request.
So now, for the big plot twist. You'd think the solution is just make everything faster on average, right? But there's a much smarter and kind of counterintuitive way to tackle this.
And that leads to this really important question. Is making the average request faster always the best way to make users happier? Well, the answer, pretty surprisingly, is not always. Sometimes focusing on consistency is way more effective.
All right, this heat map, this is the real aha moment. Let me walk you through it. Along the bottom, you've got the average time it takes to do something. And on the side, you've got variability, basically how wild and unpredictable that time is. Now look at point A and point B. Get this, B is actually slower on average than A, but because it's so much more consistent, so much less variable, they end up with the exact same overall latency. Isn't that wild? And now look at A and C. They have the same average speed, but C is just way, way more predictable. And the result? C's latency is almost 30% better. It's all about consistency.
So what's the big takeaway here? It's that predictability is king.
A system you can count on, one that's consistently pretty good without those wild performance swings, is just going to feel faster and more reliable to users than a system that's all over the place.
So how do engineers actually do this? How do you build these predictable, consistent systems? Well, it's not about just crossing your fingers and hoping for the best. It's about designing your system to handle the fact that things will slow down.
And the philosophy behind this is called software fault tolerance. It's basically the art of building a system that can keep on trucking even when parts of it are having a bad day. You just accept that slowdowns are going to happen, and you build a safety net to catch them.
Here are some of the core tools in the toolbox. You've got a retry, which just automatically tries a request a second time, hoping the temporary glitch is gone. You've got a fallback, which is like a plan B. If the fancy, complex part of the app is slow, maybe you just show a simpler, default version. And timeouts are absolutely critical. They stop one slow request from waiting forever and jamming up the whole system. It's all about failing small and gracefully, instead of catastrophically. So, at the end of the day, it all comes back to this question. After seeing how these tiny slowdowns pile up, how they can affect literally thousands of people every single day, is a system that's fast 99% of the time really good enough for you, for me, for anyone? And for any system that wants to be seen as truly reliable, the answer has to be a hard no. It's in that last, pesky 1%, that's where the real magic and the real hard work of engineering truly happens.